You know, it's one of the most powerful parts in any modern engine, but it's also one of the most fragile. It spins faster than pretty much anything else in your car, living in this crazy world of intense heat and pressure. So today, we're going to dive into what happens when it all goes horribly wrong.
So have you ever been driving and you hear this strange, high-pitched whining sound that just seems to climb with your RPMs? Or maybe you've glanced in your rearview mirror and seen this puff of blue or black smoke that you know wasn't there a minute ago.
Yeah, those things, they aren't just little quirks your car is picking up. They are massive, urgent warning signs. It's basically your engine trying to scream at you that its high-performance heart, the turbocharger, is on the verge of failing.
And trust me, this is not a problem you can just ignore and hope it goes away. A failing turbo doesn't just mean you lose a little power. It can very quickly turn into a complete and irreversible engine meltdown. The stakes here are incredibly high.
Okay, let's really get into this. The first step, really, is learning to speak your engine's language. What are the specific signs that point directly to a turbo that's on its last legs?
Well, the signs can be anything from kind of subtle to, well, really dramatic. You might first notice a sudden loss of power, like the car is suddenly struggling to breathe going up a hill. Then comes the sound, that classic, high-pitched dental drill whine, or even a metallic grinding noise. Then you look in your mirror. See blue smoke? That means the turbo is burning oil, which is its own lifeblood. Black smoke? That points to a really bad air-fuel imbalance. And of course, your dashboard starts screaming for help with that dreaded check engine light.
And this right here really underscores the danger. The expert Stephen Jackson puts it bluntly. Any of these symptoms can mean an imminent, catastrophic failure is coming. We're not talking about weeks or days here. This can all go down in a matter of minutes.
So, we know the symptoms, but to really understand why they happen, we've got to pop the hood and take a look at how this incredible little device actually works.
The basic idea is just brilliant, honestly. A turbocharger recycles energy that would otherwise be completely wasted. Hot exhaust gases, which would normally just go out the tailpipe, are instead used to spin a turbine. That turbine then drives a compressor that literally shoves more air into the engine. More air means you can burn more fuel, and that, right there, creates a huge power boost from a smaller engine. It's genius.
And this visual shows you the core of the turbo perfectly. You've got these two wheels, or impellers, on a single shaft. On one side, you have the turbine wheel, and it sits right in the hot exhaust stream. On the other side, the compressor wheel is grabbing all that fresh intake air. They are perfectly balanced to spin together as one single unit.
And when I say spin, I mean spin. That little central shaft can hit speeds of up to 360,000 RPM. No, that's not a typo. That is 6,000 rotations every single second, all while dealing with exhaust gas temperatures that can top 900 degrees Celsius. It is an absolute engineering marvel operating on the very edge of what's possible.
So you can imagine, when a part operates under conditions that extreme, it's going to be incredibly sensitive to problems. So what are the main culprits that bring this high-speed dance to a grinding, catastrophic halt? Let's meet the top 5 turbo killers.
Okay, killer number 1, the undisputed champion of turbo failure, oil starvation.
See, oil isn't just a lubricant in a turbo, it's also its entire cooling system. It's what carries away all that intense heat from the central bearing. So if that flow gets interrupted, maybe by a clogged line, low oil levels, or a bad oil pump, those bearings overheat almost instantly. You get metal grinding against metal, and the whole thing just seizes up. Game over.
Killer number 2 is oil contamination, and it's almost as deadly as having no oil at all. I'm talking about dirty oil, sludge, tiny metal particles. Even fuel can get in there and turn that life-saving lubricant into what's basically liquid sandpaper, just grinding away at the turbo's incredibly delicate internal parts.
Next up is killer number 3, excessive heat. Now, turbos are built for heat, but they do have their limits. If you shut down your engine immediately after a hard drive, you get something called heat soak. The leftover heat basically cooks the oil that's still sitting in the turbo, creating these hard, gritty carbon deposits that can clog up those vital oil passages.
Our 4th killer is foreign object damage, or FOD. And yeah, it's exactly what it sounds like. Something gets inside the turbo that has absolutely no business being there. At those insane speeds, even a tiny grain of sand getting sucked in from a bad air filter hits the compressor wheel like a bullet. A little fragment from a failing spark plug can completely shatter the turbine wheel on the other side.
That impact instantly throws the whole assembly out of balance, and it just wobbles itself into total destruction.
And our final killer? Well, it's improper operation, which is really a nice way of saying it's how you drive. Flooring it before the engine oil has had a chance to fully warm up and circulate puts a massive amount of stress on all those cold components. And like we said, not letting the turbo cool down by just idling for 30 to 45 seconds after a hard run, that causes that destructive heat soak.
All right, so you know the symptoms and you know the culprits. Now let's look at a couple of quick diagnostic checks that can help you or your mechanic figure out if there's a problem brewing.
Okay, this slide is huge because it clears up a ton of confusion. A little bit of movement, or play, in the turbo shaft is actually normal. A tiny bit of side-to-side wiggle, that's called radial play, that's part of the design. But any in and out movement, that's axial play. That is the big blinking red flag. If you can feel any push-pull motion at all, it means the internal bearings are shot and a total failure is right around the corner.
And for the more complex variable geometry turbos, or VGTs, there's another simple check. The little mechanism inside that adjusts the vanes can get all gummed up with carbon, so a technician can disconnect the electronic actuator and just move the sector gear by hand. It should glide totally smoothly from one stop to the other. If it feels gritty, or it sticks, or it doesn't move all the way, you know you've got a problem inside that housing.
So, here's the crucial point. Most turbo failures are not random. They are the end result of some other problem. So how do you fix it? And more importantly, how do you prevent it from ever happening in the first place?
Look, prevention really just boils down to maintenance and good habits. Use the high-quality synthetic oil that your car's manufacturer recommends and actually stick to the service schedule. A clean air filter is the cheapest insurance policy you can buy against foreign object damage. And remember those driving habits. Let the engine warm up gently and let it cool down after a spirited drive. And if you take care of oil leaks or other engine issues right away, you cut off turbo problems at the source.
In the end, a turbocharger is a force multiplier. It gives you incredible performance from a really compact package, but it relies completely on you to give it the clean oil, the clean air, and the proper conditions it needs to survive. It's working incredibly hard for you. The only real question is, are you doing the work to protect it?